Okay, let's take a look at the review. So here we go. It's actually pretty basic. I could have made it a lot harder, but solve each right triangle or each triangle. So on number one, I started off with a pair of opposites. So because I have a pair of opposites, I can set the law of sine. So I went sine of p over 19 equals sine of 54 over 16 across multiplied. I got a decimal, but I signed inverse the decimal, and I got about 73.8. I knew there was 180 degrees in each triangle, so I added up from 180, and so angle I got 52.1, okay? If I wanted side I just set up again opposite, so I've got I over sine of 52 equals my 16 over sine of 54. I multiplied up the sine of 52, and then I wound up getting an answer about 15.6. Area, just 1/2 adjacent times the sine of the angle, so I kind of picked these two sides, which made that my inclusive angle, okay? All right, on number two, I did not have a pair of opposites. What I had was side, angle, side. So I used a lot of cosines, adjacent squared plus adjacent squared minus 2 times the adjacent, times the other adjacent times the cosine of the angle. I got a big number, but it's a squared, so I square rooted that. I wound up with a size about 14.4. Well, once I have a pair of opposites, then I'm just going to go and find by the law of sines what sine of c over its opposite side, sine of 115 over now I knew its opposite side. I multiplied up to 7. I got a decimal, so I sine inverse, and I got 26.1. And then again, 380 degrees and, for three angles of a triangle, so I subtracted from 180, and angle T turned about 38.9, okay? And then the area, again, 1/2 the adjacent times the sine of the angle. I picked those two sides just because they're more accurate, okay? Number three, I don't have a pair of opposites, so I have to find an angle. I have side, side, side. So I found cosine of b and adjacent squared plus adjacent squared minus the opposite squared over 2 times the adjacent times adjacent. So I have to really be careful with parentheses and put that in my calculator. So I put that in my calculator. I got a decimal. I took the cosine inverse, and I got my angle. Okay, then once I get that angle, I've got a pair of opposites, and I can set the law of sine. So I did the sine of e over 43, sine of 57.8 over 39. I multiplied up the 43. I got a decimal. I did the sine inverse of that. I got about 68.9. Again, 180 degrees in a triangle, so I added up the two angles I knew, and I subtracted from 180, and I got 153.3. Area, did 1/2 adjacent times the sine of the angle, and I wound up with about 673.1 centimeters squared. Okay, I drew both triangles. So the first triangle I drew at 30 degrees. I knew this was 6.5, so if I drew the 4, you can see the 4, here, I'll show you. So the 4 is going to fit here, but you could have also drawn it, and the 4 could have fit there. So there are two different triangles. I just solved the first one. I had a pair of opposites, so I did this law of sine of b over 6.5, sine of 30 over 4, and then I multiplied up to 6.5. Yes, I got a decimal, so I sine inverse that. I got 54.3. 180 degrees in a triangle, so I subtracted from 180 the two I knew. I got 95.7. And then again, I'm looking at side C, so I can go C over the sine of its angle equals 4 over the sine of its angle, cross multiplied, and I got 7.9. Now the other triangle could have been drawn here. Now, you can see it in blue. The trick to this one is to know that these two angles are equal, therefore you can find angle B from 180 degrees. So I subtracted 180 from 54, gave me a 125.7. And then to get angle C, I know 180 degrees out of this blue triangle, so I subtracted from 180. I got 24.3. I also knew that, if I needed side C, again, I have my opposites, right? So I can go sine of C over the sine of 24.3 equals the sine of 4 over sine of 30. Cross multiplied, and I got about 3.3, okay? On the quadrilateral, I drew my diagonal here, and I had a right triangle. Well, that's pretty easy. I know how to find the area of a triangle. If it's a right triangle, it's just base times height divided by 2. So I get 56 for this triangle. Now, to get the other triangle, what I'm going to have to do is get my adjacent, adjacent, and I need my angle. So the first thing I did is I had to find this side right here, that diagonal, because that's an adjacent side of this triangle too. And I could use Pythagorean theorem because it's a right triangle. So a squared plus b squared equals c squared. Square root of 260, and I got this side to be about 16.1. Now, I've got a side and side, but I don't have the angle. Well, to do that, I found this little part of the right triangle. So that angle of the right triangle, I called it alpha. Since the right triangle opposite over adjacent, I use tangent. Tangent of alpha is equal to, I think that's an 8 over 14. I did the tangent inverse because I'm looking for the angle. I got about 29.7 for that angle. Well then, to get the theta, I called it theta, which is the angle of the bigger triangle, triangle 2, just subtracted 130 degrees from my 29.7, and I got 100.3. Okay, now I have my side, angle, side, so I can find the area. 1/2 adjacent times the sine of the angle, and I got 95. I added the two together, got about 151 centimeters squared. Okay. On the navigation, ship A is going 15 degrees towards the east at 8 knots. Ship B is going 35 degrees towards the west at 10 knots. Now they're going to go for 2 hours, so I doubled the length, 20 knots, 16 knots. I know this inclusive angle is 35 plus 15, which is 50. So I did the law of cosines because I have side, angle, side. So I did 20 squared plus 16 squared, adjacent squared plus adjacent squared minus 2 times, so 20 times 16, adjacent, cosine of 50. I took the square root of the answer I got, square root of all that, because I got d squared, and I got 15.6. Now the bearing really is 180 degrees. This is 15 because of alternary angles. So the bearing is going to be 180 plus 15 plus this angle here. Okay, so I got that angle here by using the law of sines. Sine of A over 20 equals sine of 50 over the 15.6. And I got to be about 79.1. So then all I have to do is 180 plus 15 plus 70.6. Or you can look south and rotate 70.9 degrees toward the west. And that's all I have. So I'll see you tomorrow. Hopefully you'll do great.